So write down under mesomeric and resonance effect. So they are almost equal, but not exactly equal. That's the first point you should know. When I say mesomeric effect or resonance effect, they're not exactly same. There is some small difference, but as of now, at a very early stage, we can say both are same. Okay, let's not go into detail of why they are slightly different. So I'm just using this symbol, not exact equal symbol. They're almost same. Now mesomeric can be of two types, plus M and minus M. Resonance can be of two types, plus R and minus R. Okay. What is meaning of plus and what is meaning of minus? Plus means if you have lone pairs attached to a ring and it supports the ring, that's plus M. And if you have lone pair, sorry, if you don't have lone pair, let's say if you have some group which pulls electron away out of the ring, that's minus M. So first case, you are sending it inside. The other case is you are pulling it outside. First case comes in plus M. Second case is minus M. Who is plus M? This lone pair group is plus M group. And who is minus M in this? This group which is pulling electron is minus M. Is it clear? Niharika, Chenmai, is it okay? Any difficulty in this part? Any issues in this part? Very nice. Now, how will you recognize whether it is plus M or minus M? इसको बहुत simple criteria में देता हूँ. If you have a group which has a lone pair, it will mostly send inside the ring. I'll show you something. Let's say we have a ring like this, and I put OH, or a ring like this. Let's say I put NH2. Ring like this, SH. Please draw. Keep drawing. Be a little quicker in writing today so that we can close the portions also. थोड़ा सा स्पीड में लिखोगे तो हो जाएगा. What is common in all these examples? What is common in all these examples? In all these cases, you have ring or the cyclic structure connected with some group, some element which has lone pair. So please draw. Is it clear? Adya, turn on camera, please. Adya, Niharika, and Chinmay. Is it clear, everyone? Can you observe this common feature in all of them? They have all lone pairs, right? That's a common feature. Please. Now coming to the next part. What will happen because of this lone pair? So see, due to this lone pair, we have lone pair, single and double bond formation. And this formation will be acting in this way. So this lone pair will push electron. You can create a negative charge at this place, right? Option number 1. So how will the structure look like? So the structure may look like negative charge, double O, H plus, out of 2 lone pairs, 1 is gone. I'm putting 1 plus charge. 1 plus and 1 negative is neutral. This was neutral. This is also neutral. Confirm these things. Any problem in this? Is the structure clear? So when lone pair moves here, this becomes a double bond. This double becomes negative here. Fine. And we get negative, double, and plus charge. Easy? Arav, clear? What will be the next step? Next step can be, you can say this goes here and this comes out here. Negative can reach here. Next time somebody can send this negative here. So can you draw the different resonating structures which we have practiced earlier also? Can you do that? Please note down. Adya, is it clear? Okay. Any difficulty in this? Any issues in this? So in all the cases, can we observe the same thing? NH2, sulfur, oxygen, NH, sulfur, oxygen. Check all the cases. Everywhere we are doing the same thing. Everywhere there is a common feature. The group has lone pair. Isn't it simple? So any group carrying lone pair is plus m for you. बिल्कुल सिंपल कर दिया मैंने आपको. ग्रुप देखिए lone pair है तो plus m मान लेना. Plus m के ऊपर क्या हो सकता है? That's a secondary discussion. But plus m is clear. Is it simple? The group is plus m. Now see other part. Other part is this group is other than plus m. It will pull electron from carbon. See, this is carbon. This is oxygen. O is more electronegative. It will pull with minus sign. Nitrogen, carbon. It will pull with minus sign. Sulfur, carbon. अब सल्फर कार्बन में सीक्वेंस देख लो. फ्लोरीन, ऑक्सीजन, नाइट्रोजन, क्लोरीन, ब्रोमीन, sulfur, carbon, iodine, hydrogen. This is a sequence. So sulfur is still above the carbon, slightly pull. Oxygen, pull. Sulfur, slightly pull. Oxygen will pull. Nitrogen pulls. Nitrogen pulls. Oxygen pulls. Oxygen pulls. Again. So can you observe? Though they are supporting the ring, but they're pulling it away also. Pulling it towards them. I repeat. It's like giving back, taking it back. Giving and taking back. But the one which is giving is what? It is plus m. It is plus m. Positive mesomeric. And the one with which you are taking back is just minus I. अब होता क्या है? Plus m is much more bigger as compared to छोटा minus I, small minus I. So eventually they end up giving. Okay, you give someone 10 pencils, take one pencil back, eventually give 9 pencils. Simple. So plus m is a huge thing. Plus m is much more important because it's coming out of resonance. Okay, Rupesh, can you just turn this to my side? It will be easier. So plus m is perfect. Plus m is pushing inside and minus I is pulling it back. Easy. All these cases, feature is similar. I hope you understand this. Any problem, please ask. यहाँ तक कोई दिक्कत है तो पूछ लीजिए. Clear हो गया? Mesomeric effect is clear. Inductive effect is clear. So can you give me example of group which is having plus m and minus I? What will be your answer? If I ask you, give me example of groups which are having plus m and minus I. Akshay, what will be example? Can we say all OH, NH2, SHO, this, everybody is doing plus and minus I. But if I ask a question, Chinmay, give me a group which is plus m and plus I. अब क्या करोगे? Chinmay.
I'm not sure, sir.
Okay. Anyone who can answer this question? Plus m and plus I. Huh? Carbon ion, C negative. But C negative will push electron with plus m. That's a good thought. Iodine again, iodine is anyways a mild puller. So you have to find something which can push electron to carbon, right? That's how the thought is. Now write down this, and this is a very important question also. I'm highlighting it separately so that you don't forget this. Write down groups like O negative, groups like NH negative, okay? Groups like O negative, groups like NH negative. these kind of groups where you already put negative charge, they start pushing electron. Now you can say, sir, oxygen is electronegative. Why it is pulling electron? Why not it is pulling electron? Because it is O negative. So O is having not that much space where it will pull. It will start pushing electrons back. Fine. Because of this negative charge. So O negative will push electron back. NH negative will start pushing electrons back. It will pull. No. It will push with plus I. It will push with plus M also. So they are plus M and plus I group. Please make note of it. This is an important question. Everybody please make note of it. This is an important question. Clear हो गया? Niharika, is it clear? Chinmay? Adya? Any issues with this? Any problems with this part? Can we go further? Please note on the heading, write on the heading, minus M groups. Minus M groups देखते हैं कि minus M groups क्या होते हैं? Minus M groups. Can I remove this discussion? Okay. Write down minus M group. Minus M is also called negative mesomeric effect. Negative mesomeric effect, which is observed when the group is available, which is pulling electrons, right? So it should pull electrons. Now, what kind of group will pull electron? Think electronegative, and there should be some kind of bonds which can take it from there. So let's see this example. What is special about it? Please observe, oxygen is more electronegative than nitrogen. So this pulls here and this pulls like. देखो बाहर जा रहा. Can it send inside? There is no lone pair. It can't send inside. Can you observe the type of group, variety of group? Okay, chale. So start observing. I'm drawing certain structures. Please observe and try to answer, please, accordingly. Find out something is common in all the examples. Keep drawing. Please note down all the examples. What is your observation in all the cases? What is the common thing that you observe in all the cases? Yes, E1, E2 multiple bonds. So if I say this is our E1, this is our E2, E1, E2 double bond, and E2 is more electronegative than E1. E2 is more electronegative than E1. E1, E2 double bond. Even triple bond will also work. So I can add some examples as in this. Keep drawing. Check. In all these questions, you will find the same feature. And the feature is very simple, very clear. It's this. Observe what I'm trying to show you. Chinmay, is it okay? Niharika, Adya? Very good. So I hope this part is pretty much clear to all of us. In all these cases, we have E1, E2 double bond or E1, E2 triple bond, where E2 is more electronegative than E1. This is always going to be minus M group, puller. Now, when it pulls, what will happen? See, when you pull in this way, what will happen? So let's say you pull it like this becomes negative, this end becomes positive. Deficient ho gaya, no, remember? You pull it like this becomes negative, this becomes positive. You pull it like this becomes positive, this becomes negative. Negative, positive. This pulls, and this pulls. Check please. ये chain बन गई पूरी. Alternate double bonds. This becomes positive and this becomes negative. Similarly, this pulls, this negative. Pulls, negative, 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 negative. कर लोगे? I hope you understood this concept properly now. Plus M means support with resonance or conjugation. Minus M is pulling with resonance and conjugation. Plus I means pushing with electronegativity differences. Minus I is pulling with electronegativity differences. Done? So this much is clear. You understood plus M, minus M properly. Now I'm again asking the same question. Minus M and minus I group. Tell me if you have both. Minus M and minus I group. इसमें है. Is it minus I? How will you decide is it minus I? It will pull. This 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 will pull. Pull, pull. Okay. देखो देख रहे हैं minus I सब में. Everywhere you have the same feature. All the groups which I have written here, coincidentally, they are all minus M and minus I. So my next question, you can guess. What will be the next question? Minus M plus I group. क्या ऐसा कोई है जो वैसे तो माइनस एम हो बट वैसे प्लस आई भी हो जाए? अब बताइए. यस, श्याम. Yeah, but that's not asking. So can there be a group which has both minus M as well as plus I? So generally speaking, this is almost null. Okay, this is almost null. We can have one or two examples we can create randomly, but as of now you keep it as null. Okay, very rare, very 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 rare. Okay, कि माइनस एम भी हो रहा है और प्लस आई भी हो जाए. यानी आप बोल रहे हो कि भाई ये पुल भी कर रहा है और electronegativity is the reason behind minus M, in conjugation, and then it is pushing it back. So that's become null. Fine. These are the cases that you should know, and if it is clear, that means you understood plus M, minus M, plus I, minus M. Fine. All effects are clear up to this point. What is plus R and minus R? Plus R and minus R are exact as plus M and minus M as of now. So that difference we will discuss maybe sometime later once you are very much comfortable in organic, then we can talk about that part. What is plus R? What is plus M? How they are small? What is the small difference in these two things? But that's not at the current point. Shall we? So if this is clear, I can move forward. Can I remove this? So in minus M cases, you're getting plus charges here, here, and here. And the same in plus M cases, you're getting minus charges here, here, and here, right? So how many of you can observe that in both the cases, you are getting charges. Let's say G is a group, Let it be plus M or minus M, you're getting charges here, here, and here. Nobody's bothered about meta position. This is called ortho position, this is meta, and this is para position. I hope you know this. Ortho, meta, para. So meta position, nothing is coming. If it is plus M, there is no charge coming up. If this is minus M, still no charge is coming up. Is it clear? But remember, if it is plus M, you are getting a minus charge here. Hence, these positions are activated to attack on electrophile. Because they are negative, they will look forward for E plus. When these positions become plus in presence of minus M group, like in this case, these positions become useless for electrophile. Hence, relatively, meta becomes better position. I repeat my sentence. If it is a plus M group, minus charges are appearing at these three places. Hence, these positions will try to involve electrophile on these places, right? But in minus M case, these positions which are marked as plus here, right? They're useless because how can plus attract plus? So the position which is not having plus becomes a better site for attack of E plus. Hence, meta becomes better. It's like, I'll give you a practical scenario. So let's say there is someone who is good in some particular sports activity and that person is not participating, and because of this, someone is getting, let's say, first. So it's basically because of absence of that, it is becoming first, right? Not because of the reason. Understand? So try to understand. In this case, meta is good for E plus, not because of its virtue or some property. It is good for E plus because others are much more bad or worse. Are you understanding this point? This is a very interesting point. Please try to understand. इस पे एडवांस का क्वेश्चन आ चुका है इसी स्टेटमेंट पे जो मैं बोला स्टेटमेंट. Meta position does not attract E plus because of its virtue. It attracts E plus because orthopara is bad. You understand this statement, please? Niharika, Adya, Chinmay. So be very careful about this statement. This is very important line. Are you sleeping properly? Why your eyes are red? Huh? But you look like very tired. What happened? Played a lot in school today. Take care of your health, everyone. Can I remove this? Akshay, written, Sanjana, Sham, Arav, लिख लिया? इधर पे चिन्मय, निहारिका, आद्या, written. Very good. तो चलिए आगे बढ़ते हैं हम लोग further discussion पे अपने. So our next discussion is, I'll just review it quickly and then we'll proceed. Now look at this diagram. I have shown OH. I have shown how charges will move. You know already. Please don't copy. You know this. You know this or not? How lone pair moves and all. So where is charge forming? This position, and this position. And you can draw the structure. Fine. You also know what are these groups. So already we understand this part. What is best for E plus attack? Plus M plus I, because it will make the ring rich. What is worse for E plus attack? Minus M minus I. Okay. Minus M plus I is rare. And yeah, that's all. Okay. Please note down this thing. VSA means very strong activator. Just write down. Very strong activator. Just draw this table. What is the meaning of very strong activator? So the meaning is simple, that if you have E plus with a plus M plus I situation, then ring is highly activated. Ring is highly activated. The ring is having lots of electron and they can easily go and attack on E plus. So we call it very strongly activated for E plus within bracket SEAR. SEAR I have done in the earlier classes. Can you recall? Electrophile आता है, H को replace करता है. Okay, benzene ring पे you put CH, CH3, CH3 in all those cases we have done. Can you complete it? Great. So this table is basically a simple summary of our discussion. And whatever we are discussing is for electrophile. You can ask, sir, why it is electrophile? Why are you not discussing about nucleophile? Because benzene ring is rich with electrons. Hence, we can talk about electrophile. Okay. So Try to understand. If tomorrow somebody asks a question that you have a group like this, which is O negative, and you have E plus, let's say in format of NO2 plus, or let's say in format of CH3 CH3 plus. So what is the correct placement of these groups? So you'll say, fine, these groups are electrophile, this ring is rich and all. These positions are activated. I can place any of these three places. Okay? Understand? The same question comes, but this time, let's say they give NO2. The question comes, you will try to put it here, if possible, right? Because ortho and paraposition will not be used. Sajna, is it clear? Arav, is it clear? And moreover, with NO2, it will become difficult also. Maybe nothing will come because this is highly deactivated. So maybe this will not react also. We'll talk about it. Is it fine? Chal. So आगे बढ़ते हैं अपना discussion पे. Minus M is pulling electron away from the ring via resonance. I have shown you examples earlier. You've written it down. No need to copy again. So technically, you have four possible scenarios: plus M minus I, plus M plus I, minus M minus I, minus M plus I. 1, 2, 3, 4. Out of 1, 2, 3, 4, plus M plus I cases are when plus M plus I cases I have mentioned O negative wala case, right? Plus M plus I case was O negative wala case. NH minus wala case, right? Minus M minus I cases we have seen earlier, right? A lot of minus M minus I cases we have seen. Plus M minus I case, I said it is a rare case, right? Okay. Now, this is lone pair part. This already we have discussed. Let's not go into this. NO2. Can you just practice one structure? You want to draw or you know this? You know this, all of you? Minus and plus I is rare. Plus and minus I, we have examples, a lot of examples. Please draw one of these at least. Just draw maybe NO2. Okay. Just draw NO2. Don't look at here. Do it yourself and then check. Just for practice. I know you know this, but just for practice. Please draw resonating structure of NO2. And remember, in all the cases, I'm drawing 5 structures. 5 resonating structures. Okay. Please complete it. ठीक है? You please draw and then check. So if you remove plus comes here, then here, and then eventually you have to give it back. Normal structure. See the first one, the last one, you'll find the alternate placements of double bond. कर पा रहे हो खुद ही अपने आप? अगर कोई भी mistake आपने की है, then please do it for CN also. कोई भी mistake किया तो CN के लिए भी बना लो एक बार. कोई दिक्कत वाली बात नहीं है. Niharika, I hope you're doing this.
Yes, sir.
Okay, good. Chinmay done? Good, good, good. Very good. Can I proceed further? Anyone having any doubt? Please ask. Sham, any doubts in the bond movement? I think now you're comfortable with bond movements and all. These things you understand very well. क्या हो रहा है movements and all, because this will be required in 12th standard again. So please work upon these things. Look at for CHO. Look at for CHO. Same thing. Look at for CH double bond NH. यहाँ पे lone pair थोड़ी है, तो this will also pull. Can you understand all these structures? How I'm drawing? Look at for CO. If you want, you can please copy, just for practice. If you have any doubt, any trace of doubt, you can just copy these structures. But I'm pretty sure that you know most of the things, and you can do it yourself. I hope my assumption is not wrong. Let me just check. Or I draw. Sanjana, done? So while doing it, you have to move this also here and this here. So यहाँ से इसको भी लेके आइए. अरे रेड से लिख रहा हूँ, ब्लू ले लो यार. Why are you writing with red pen? Okay. Done. Done, Sham. Good. Yeah. So last one, send it here. Send it here.
That's the same.
Yeah. So I think all these cases are pretty much similar only. ये ऊपर चला गया. CN, CHO. Can you find common thing in all of them? Which charge is being formed? Ortho position, para position, ortho position. Which charge is being formed? Plus charge. कर लोगे draw? Niharika, Chinmay, Adya. Can you take it as assignment or something and complete it at your own pace? These cases लिख लीजिए, नोट कर लीजिए. सेकंड केस आपने लिखा CN, थर्ड केस CHO, थर्ड केस CHO, फोर्थ केस CH डबल बॉन्ड NH, CH डबल बॉन्ड NH, फिफ्थ केस CO NH2. प्रैक्टिस करना प्लीज इनके लिए. There is no one which is plus M. They are all pullers. How do you know they are pullers? Because it's even into multiple bonds, pulling it away. Is it clear? They are all pullers. So same ही काम सब में होना है. थोड़ा बहुत bond आप change करोगे, but that's all. Rest all is same. CO NH2 लिख लिया? Okay. Now what I'm writing here is plus M groups OP director, minus M group meta director. I hope I explained the reason for the same and you have understood also. Anyone having any confusion, please ask. Chinmay, any doubts? Niharika, Adya in this line? SEAR reaction, E plus reaction for plus M is OP director, minus M is meta director. Any doubt in this? No doubts? Chaliye. Write the heading hyperconjugation in detail. We have to do hyperconjugation. Hyperconjugation. Point number 1 जो सबसे पहले मैं लिखवाना चाहूंगा, note down that point. Conjugation is more effective than hyperconjugation. तो बोलोगे सर ये हाइपर है, फिर भी आप बोल रहे हो कॉन्जुगेशन ज्यादा स्ट्रांग है. So don't go by the word, don't go by the English meaning of hyper. Hyper means, yes, hyper means higher, ऐसा लगता है. But hyperconjugation is not superior than conjugation. This is the first common mistake with 90% students. Okay. So first point आप लिख लो, conjugation is superior than hyperconjugation. पहला point तो यही हो गया, basic. Now, what is hyperconjugation? This is also known by various other names, by the name of the persons who found Baker and Nathan. So Baker-Nathan effect. No bond resonance. Normally, we don't see a kind of bond moving and that kind of thing that is normally there in double, single, double and all. So it's called no bond resonance. This is also called sigma to P vacant orbital support. Sigma, but I'll explain you everything. Don't worry. Sigma to P vacant. That's why it is also called sigma to P vacant. Conjugation is superior than hyperconjugation. Inductive effect in conflict with hyperconjugation. Inductive effect will lose, hyperconjugation will win. And the final sequence is conjugation, hyperconjugation and inductive. CHI. Okay. China याद है ना? China का CHI. Huh? Mesomeric will be somewhere. Mesomeric is conjugation only. What is mesomeric? It's conjugation, no? It's resonance, right? Please complete this. Note down all the points. I'll explain you what is meaning of this and this. I think इसमें तो कोई confusion नहीं होगा. इसका नाम ऐसे भाई नाम है. इसमें भी confusion नहीं है. इसमें भी नहीं है. एक ही confusion हो सकता है, which is on these 2 points. And then one more point. Hyperconjugation can be of 2 types: plus H and minus H. Plus H and minus H. Mesomeric can be plus M and minus M. Resonance can be plus R and minus R. Inductive can be plus I and minus I. Likewise, hyperconjugation can be plus H and minus H. ठीक है? Minus H को बोलते हो आप reverse hyperconjugation. We'll talk about this also. Reverse hyperconjugation. Next 1.5, 2 months, you have to put lots of effort because you have done everything. Now you have to just brush it up and go in 12th standard with full energy. So we should not leave any stone unturned. पूरी energy से जाना है. 11th अच्छे से यही पे complete करना है. We should not be a student जिसने 12th में भी 11th revise कर रहा है या 11th के doubts पूछ रहा है. No, we have to finish it off here itself and then move to 12th standard. That should be the aim. So 15th March to 31st March, we'll be giving you a complete review of 11th standard, complete revision of 11th standard. 15 to 31, physics, chemistry, maths, all. So let's say daily one topic will be completed, something like that. Or let's say in 2 days one topic will be completed. Okay, तो उस पैटर्न पे हम लोग प्रैक्टिस करेंगे, थियरी करेंगे सारी, and then further it will be taken up. Is it clear? So idea is that 1st April when you enter 12th standard, you should know everything in 11th properly. वहां तक आपका सारा रिविजन, रिव्यू, कुछ टॉपिक छूटा है, कुछ पढ़ना है, सब बता देना, सब करा दिया जाएगा. कुछ आपने मिस कर दिया, कुछ आपको समझ में कम आया, you please tell us upfront that this is the problem, we will solve it. Okay, is it clear? And then once you enter 12th standard, you should go with full energy that yes, I know everything, now things are clear. Done? Chinmay, Niharika, Adya, is it clear? Chali. So let's understand what exactly is hyperconjugation in real sense. So let's do it. Okay, let's do it. Hyperconjugation. Write few points, few more points. You've written only few points. Add few more points. This is used to explain. This is used to, or this theory is used. See, this is a theory, right? Hyperconjugation is a concept, it's a theory. This is used to explain stability of carbocations, comma, stability of alkenes, okay, and stability of aromatic compounds connected with alkyl groups. Aromatic compounds connected with alkyl groups. I'll explain how and why. So I hope you have written carbocation, alkene, and alkyl group, which is like aromatic group connected with alkyl groups. So now just see. Let's say we talk about CH3. भाई थोड़ा ध्यान से समझना because I don't think कि आपने स्कूल में भी डिटेल में किया होगा. Have you done it in school in detail? Yes or no? No. तो उसको थोड़ा डिटेल में करेंगे so that ये पूरा क्लियर हो जाए कॉन्सेप्ट. And इसके मेंस एडवांस के क्वेश्चंस आपसे होना शुरू हो जाए. You solve any question, it should happen. Same for NEET also, right? So question should be solved. Please draw this, and we'll go very slow now. We'll go very, very slow because this is very important concept and you have no idea about this earlier. So we'll just go into fundamentals and try to understand everything properly, right? What is this C plus called? This C plus is called carbocation, or you can say carbonium ion, or we can say carbonium ion. EM is basically positive. So carbocation. Go to the next carbon. This carbon is known as alpha carbon. This position is called alpha, and this carbon is called alpha carbon. And hydrogens which are connected here on this alpha carbon are named as alpha hydrogens. So first of all, we should know the naming. Who is where? What is this called? Is it okay? Clear? Clear? All three of you? Niharika, Adya, Chinmay? Chinmay, you are there?
Yes, sir.
Okay. Now, look at this discussion carefully. Carbon is having plus. What is carbon's configuration? It is 1s2, 2s2, 2p2. Please write down. 1s2, 2s2, 2p2. Carbon is 6. This is known as ground state configuration of electronic configuration of carbon. And we know from chemical bonding this part. This is called GS or ground state configuration. What is ES? Excited state configuration of carbon. So we say carbon will become 1s2. 2s will be having 1. And 1 electron jumps to 2p. Hence, this is the new situation. And this explains why carbon has 4 valency. These are 4 things. 4 hydrogens come, become CH4. 4 carbons come, become CC, like C4. Cls come, CCl4. Right? This is the reason behind carbon's 4 valency. ये सबको पता है? इसमें कोई doubt? Now see, this carbon is a special carbon. This carbon has a plus charge. Plus charge means one of these electron is removed or it is not there. ये वाला नहीं है. यानी अब situation क्या है मेरे पास? ये हो. Okay. So I'm saying this is a C plus situation. Are you understanding? एक electron उड़ गया है ही नहीं. So this is the case. Can I say this is indicating a vacant orbital? This is indicating a vacant orbital. Which orbital are we talking about? 2p. Now 2p is, can be x-axis, 2px, y-axis, 2py, z-axis, 2pz. Now, let's say I consider that one of the orbital is vacant. It can be in any direction up to your choice. I can draw it like this. It's a vacant orbit. Now come to other side. This is a carbon-hydrogen bond. What kind of bond is this? So this bond we normally call sigma bond. In the language of chemistry, we call it sigma bond. Sigma bond, if you recall, remember this question. If I give you C double bond C, HH, HH, this is sigma, this is sigma, this is sigma, this is pi, sigma, sigma. So in double bond, 1 sigma, 1 pi. We know this, right? So this is a sigma bond and this is a vacant orbital. Can you observe this much and please draw this much? Write down this, write down this. यहाँ तक पहुंच जाओ. नोट कर लिया? यहाँ तक पहले आप नोट कर लीजिए, समझ लीजिए यहाँ तक पूरा. How many of you remember back bonding from chemical bonding? Chinmay, what is back bonding from chemical bonding? Can you answer, please? Chinmay, can you hear me? Please answer, what is back bonding? Unmute and answer.
Sir, back bonding is hydrogen bonding within the molecule.
Hydrogen bonding is different. Back bonding is different. Have you done back bonding?
Yeah.
What is back bonding?
Vacant here.
So back bonding, in short, if I just quickly revise it in this small box, write down back bonding. Back bonding is second and third period members, one having vacant orbital, other having lone pair. Lone pair supports vacant orbital. Can you recall? This is called back bonding. Examples were BF3. Fluorine supports boron in vacant orbital. Because of that, the BF bond becomes shorter. We have done these things or not? Can you recall? Or example could be, there can be many examples, right? Let's say another example can be N with 3 SiH3. 3 SiH3. These electrons are dragged in vacant orbit. Hence, lone pair is absent. Hence, it is trigonal planar. Can you recall these examples? This was back bonding. Don't you think that something like this is happening here? You have a bond, you have a vacant orbital. The only difference is you don't have a lone pair. Had it been lone pair, you would have formed the permanent bond. Since there is no lone pair, there is just presence of electron, which is due to sigma bond, and there's a vacant orbital. We can't shift it completely and say, okay, take it. Is it clear? So what happens? What is hyperconjugation? Hyperconjugation is a phenomenon which shows or which describes stability of these carbocation with effect. Just draw this. So what I've done, I've taken the sigma bond to P, which was vacant. I've taken a sigma bond to a P. This is your P vacant. And this is known as hyperconjugation. So ये question IDJ का question है. Options were given sigma to P vacant, pi to P vacant, pi to pi, sigma to sigma. ऐसे चार options दे दिए random उन्होंने. Which option will mark? Sigma to P vacant. This is the actual IDJ question. Once you solve PYQs, you'll come across this question. So sigma to P vacant is called hybridization. Now what will happen because of it? Because of it, can I say this carbon, hydrogen, you get a double bond here, hydrogen, you get this kind of alkene. And this H who is losing electron will be in the closed vicinity of the compound. So this is represented as this. Remember, you cannot run away with this H plus. You can't take it out and अरे हो गया ये H plus निकल गया, ऐसा नहीं कर सकते आप. It is, this theory is just explaining the stability of carbocation. It does not say that this H is acidic or something. I repeat my sentence. It does not conclude as this H is acidic. Is the statement clear? Shyam, okay?
So it stays in that compound.
Yes, it remains in the vicinity of the compound. Just write down this word. This H plus remains in the vicinity of compound. You can't take it and run away. Very important point. बहुत से लोग इसको acidity समझ लेते हैं कि अरे वाह कार्बोकेटन दिए चलो H निकाल के भागते हैं और एक एल्कीन बना के दे देते हैं आंसर में. नहीं होगा. It is not possible. Niharika, is it clear? Adya, Chinmay? Very good. So I hope this part is now pretty much clear. Should be okay. So in this case, how many such hydrogens do you carry who can have this capacity or capability? One is this. Of course, other can be this. And third can be this, right? These three are equally placed scenarios. These are all same, right? अभी ऐसा कुछ special थोड़ी है H में जो इसमें नहीं है या इसमें नहीं है. All are same, right? So for that matter, you can take any of the H. So we can say that we have got 3 alpha hydrogens which can explain the stability of this carbocation. This is what is hyperconjugation in simple words. Is it clear now? Now next time if I give you any alpha H, you have to just count and you can talk about the stability of carbocation. And this first part will be taken care of. Is it okay? Can I remove this?
Less number of alpha have like significance, like more alpha or more stable.
Yeah, I'll come to that. That is the next discussion. Any problem with this part? Anybody? Any issues? Can I remove this? You've written, all of you? Good. So चलिए थोड़ा सा इसको और डिटेल में समझते हैं. So let's say a question comes when you have C plus and you have CH3. With respect to this carbocation, please count alpha carbon. So give me alpha carbons, how many? Give me alpha hydrogens, how many? Next question, C plus CH3 hydrogen. Same question. Alpha carbon, how many? Alpha hydrogens, how many? Next question, C plus just CH3, 2 hydrogens. Alpha carbon, how many? Alpha hydrogen, how many? And the last case, C plus H, and one more H. Alpha carbon, how many? Alpha H, how many? And then C plus CCH3. CH3. Alpha carbon. Count and write quickly. Be real fast. Note down and then write. Copy the question first. अभी बहुत अच्छा लग रहा है, बाद में सब भूल जाते हैं, इसलिए please note कर लो. Please note down. No compromise on your notes. लिख लीजिए please. अक्षय जी note करिए सारे cases. And then write alpha carbon and alpha hydrogen. किसी का solve हो गया? Anyone was solved? On board. Hmm. How many? So like 0. बैठे. Any changes? If any changes, you can cut and write your answer next to that. Any other changes?
Yes, sure.
Any changes? आरव वो खो गया अभी. क्या चल क्या रहा है? कैसा? Okay. Any changes? Niharika, Chinmay, Atya.
No, sir.
Do you agree with the change which Shyam has done? Shyam has made some correction. Do you agree
Yes.
with that? With respect to this plus charge, we have 1, 2, and 3 carbon. Don't count this carbon. This is beta carbon. ये alpha है, अब beta चले गए. Is it clear? Alpha ये वाला हो. And there is no hydrogen because I have replaced all the hydrogen by CH3. So this is correct. 3 and 0 is correct. I hope this question is fine. Now please take a short break, not very long break of 10 minutes, and we continue at 3:15 sharp. Steric crowding means? Welcome back. So we can count alpha hydrogen, we can count alpha carbon. Niharika, Chinmay, Adya. ऑफलाइन वाले आ गए, ऑनलाइन वाले क्या? तीनों ही गायब है। हाँ, it's already over, right? हाँ, 317. Chinmay, Niharika, and Adya, can you hear me? Chalo, let's start then. So if you see, the one which is having maximum number of alpha hydrogen will be the most stable. Then second, then third, then both are zero. So they will be like fighting for fourth placement. Now, which is worse? This one is bad or this one is bad? How do you decide? Now, this is very bad structure. Why? Because on C plus you are putting so many groups, which is a good amount of. There's a word used for it: steric crowding. Steric crowding, note down. Steric crowding means lot of traffic basically. So due to this plus charge will be highly unstable. You're putting so many CH3s like this, it will make the whole system unstable. So ये worse चला जाएगा, इससे भी ज़्यादा, ठीक है? This one is best. 1, 2, 3. Okay, because of 9 alpha H. So alpha H is the guiding principle for stability of this. More alpha H, more hyperconjugation structures. No, vacant orbital is one only. More H can support. This can also support. This can also support. This can also support. That's what we discussed before break.
Okay,
Yeah, same thing. C plus.
I got it.
Can you recall? This. Okay. So this is the first case which is telling you about carbocation stability. Chinma, are you back? Now coming to the next case. इसको पहले एक बार नोट कर लीजिए. Can you proceed further? चलिए आगे बढ़ते हैं. So I'm removing it, considering that you understood this. So quick review of hyperconjugation. This part is clear. This is also clear. How do we count alpha H? That part you understand. Now I'll come to the double bond part, but before that, this is also clear. This is more stable in the sequence. This kind of question, 6, 3, 2. 3 is better than 2. Remember, this is ethyl group, but methyl becomes better. Normally, inductive effect will say ethyl is better. So this is a fight between inductive and hyperconjugation. Inductive says this is better. Hyperconjugation says this is better. Who's the winner? Hyperconjugation. So actually, this is better as compared to the previous. Is it okay? Please note on this example. And then we go to these kind of questions you can easily answer now. How many alpha H are there? Should not be a problem for you. Then I'll come to stability of alkene after this. Please note down this. Then I go to stability of alkene. Complete this. Note these examples. Clear, Sham? How was your score this time in chemistry exam? All of you. Out of how much it was? 25. कितना स्कोर किया था? भूले तो नहीं होंगे? ऐसा बोला कि मैं भूल गया. What was the score, Sanjana? 19. आपका अक्षय जी? 17. 18. 17. इधर ऑनलाइन वालों के क्या नंबर थे केमिस्ट्री में? भूल गए या याद है? या आवाज नहीं आ रही? आवाज नहीं आ रही. चलो कोई बात नहीं. ठीक है, कोशिश करो कि इसको इम्प्रूव करो. पेपर वाज डिफिकल्ट. 25 क्यों नहीं है किसी के? 25, 24 क्यों? डिफिकल्ट था पेपर.
No one got it.
What is the highest? Who?
Top sharing, sir.
Okay. Done. Any doubts in this? Can I go proceed further? चलिए लिखिए next. Stability of alkene. Yeah, this is 2 alpha hydrogen. This is 3 alpha hydrogen. No, alpha. This is beta. So 2 and 3. So I'll mark this as better. But as per inductive effect, this is better. Okay, because ethyl inductive effect is considered better as compared to methyl effect. But who's the winner? 3 alpha H, hyperconjugation. Whenever there's a conflict between hyperconjugation and inductive, the winner is hyperconjugation. यही सीखा हमने, right? Chinmay, are you back now? बहुत दूर निकल गया लग रहा है. चलो, let's see whether he's back in the class. Anyways, coming to the next part of the story, that is alkenes. Yeah, एक बार check कर लेते हैं. Can you hear me, Niharika and Aditya? So what was the score in chemistry, if you can hear me? अभी नहीं सुनाई दे रहा. Okay, चलो. Let's not disturb them. Write down stability of alkene. This is second application of hyperconjugation. लिखिए. Second application of hyperconjugation is stability of alkene. You can tell about stability of alkene. So now, first application was the previous one which you have done, stability of carbocation. So let's say we have these structures. Please draw. And थोड़ा speed में draw करने की कोशिश करो. Calling it 1, 2, 3, 4, 5, 6, and 7. Please draw without mistake. कुछ गलत मत draw कर लेना. Chinmay is back. What happened, Chinmay? Where were you?
So I was here, I forgot to turn my camera on.
Okay. Please note down this. Done. So just see the first example, for instance, or let's say we can take this one. If you give it H plus, how will it look like? If you give it H plus, it will become H plus CH3, H and hydrogen. That can be one option. Or it can be H These are the two probable options. Please draw. These are two probable options. या तो यहाँ पे प्लस चार्ज आएगा एच इधर आ जाएगा, यहाँ पे प्लस चार्ज आएगा एच इधर आ जाएगा, यही तो हो सकता है, दो ही चीज हो सकती है. Now please tell me, out of these two structure, which will give you more hyperconjugations? If you see this structure, this is alpha carbon, there are two alpha H. And look at this structure, this is alpha carbon and this is also alpha carbon. That way. Can you observe? So which position is better position for plus charge? This position. ये भी आप इससे ही तो बता सकते हो easily, right? So when you discuss stability of carbocation, you can again take help of this method while deciding it. That's one criteria. Is it okay? How many of you understand this logic? What I'm trying to convey? Second important thing. If I consider the C double bond C as a pi orbital, right? And let's say you have a CH here. Out of 3 CH, I'm drawing it like this. So this is a sigma and this is a pi. And when you want to discuss any kind of hybridization in this, what is the possibility? Possibility is if I break this bond, keep negative here, keep positive here, I can again talk about hyperconjugation. Because when a double bond breaks as a minus and plus, the plus and the next carbon with alpha hydrogen, we can talk about hyperconjugation. This is how we can talk about hyperconjugation for this particular scenario or stability of alkene. So if you see this C double bond C, these are my alpha carbons and these are alpha hydrogen. So 3 plus 3, 6, 3, 9. If you see this one, 3, 3, 6. If you see this one, 6. This one, 3 and 3, 6. This one, just 3. This last one, 0. And the first one, 12. Do you understand this? This is how we count alpha hydrogen. So you have C double bond C. You'll go to this position count and you go to this position and also count. Both side you're counting. इधर का alpha ये मिला और इधर का alpha इधर मिला. Is that clear? Chinmay, Niharika and Adya, is it clear? How do we count alpha? And logic behind is also clear because we can give H one side and give H other side. So out of 1, 2, 3, 4, 5, 6, 7, if you have written, all of you have written 1, 2, 3, 4, 5, 6, 7, which is most stable alkene among these? Your answer would be 1, better than 2, better than 3, better than 4, better than 5, 6, 7, 8 and 9. Now, this is the order of stability. Please note down. Question comes, why and how? Because 12 is bigger than 9, understandable. 9 is better than 6. 6 is better than 3. 3 is better than 0. That's okay. But how will you decide this 6, and this 6? That can be a key question here. These all are 6. So how I'm telling that 3 is better than 4 is better than 5? This is the problem area. Yes or no? Because all are 6. How are we deciding that 3 is better than 4 is better than 5? Because in 3, if you draw 3 carefully, you can get this possibility. So see, all 6 alpha H are present on same carbon. Hence, it can form a 3-degree carbocation. Are you understanding? That means its hyperconjugation is more stable as compared to other two, where one will be 3, other will be 3. I'm counting 6, but this is 3 and 3 separate. This is 3 and 3 separate. This is 6 together on the same carbon. So I hope this is clear that this 3 is better than 6 together is better than 3 plus 3. अब क्वेश्चन आता है why 4 is better than 5? Because 4 is trans. Trans senses आपने पढ़ा हुआ है? Trans is more stable. Trans is more stable. The reason is this is having diagonal symmetry. CH3s are away from each other. They will not create any repulsion, hence become stable structure. Okay. So trans के लिए क्या क्या चीजें अच्छी होती है नोट कर लो एक बार फटाफट. Trans के लिए क्या क्या better है? Trans has better what? Tell me. Let's. Trans has more symmetry. Note down. Trans has more symmetry. Trans has higher melting point. I repeat, trans has more symmetry. Trans has higher melting point. Trans will have lesser boiling point. चलो इसको mix मत करो, confuse हो जाओगे. Just write higher thing first and let other one I'll write for the other high, right? So trans has more symmetry. Trans has more melting point. Is that okay? Now coming to cis. Cis has more boiling point. Cis has more boiling point. More dipole moment. More boiling point. More dipole moment. Okay. Now I hope you understand the whole thing. If symmetry is more, dipole moment will be lesser because symmetry will cancel out moment. Yes or no? Symmetry will cancel out dipole moment. So symmetry is more means dipole moment will be lesser. So trans is a non-polar compound. This is a polar compound. So I hope this is now clear why 4 is better than 5. The sequence is clear. If you know the sequence, can I say this is most stable alkene? If a question comes in exam, which is least stable alkene, what should be your answer? Write down. Write down.
Yes.
Ninth one is least stable alkene. Oh, sorry, seventh. Seventh one is least stable alkene. Seventh one is least stable alkene. One more line for seventh one. Seventh one is most reactive alkene. Least stable और most reactive बहुत पूछते हैं एग्जाम में. कंफ्यूज नहीं होना आपको. जो least stable होगा वो more reactive होगा यहाँ पे. Is it clear, चिन्मय? चिन्मय आज थोड़ा इधर उधर ध्यान है इसका, कुछ तो कर रहा है अलग एक्टिविटी. What are you doing, चिन्मय? Other than study today, what are you doing? Normally in class you are very focused, but today I cannot see focus.
So I'm just tired.
Okay. Okay. Fine. So what I was discussing?
The most, yeah.
Yes. So ninth one is least stable alkene. Ninth one is most reactive alkene. ये भी एग्जाम में क्वेश्चन आ सकता है आपसे. And this is of course least reactive alkene because most stable alkene है. ये रिएक्शन में पार्टिसिपेट नहीं करना चाहेगा जल्दी. ठीक है. अब एक और चीज बताओ. Have you heard of term heat of hydrogenation? अरे थर्मो में पढ़ा है, सीधे मना कर दिया इसने. थर्मो केमिस्ट्री में पढ़ा है ना, हीट ऑफ हाइड्रोजनेशन, हीट ऑफ कंबशन, एंथैल्पी ऑफ हाइड्रोजनेशन. Yes or no? Enthalpy of hydrogenation सुना है. Delta H सुना है hydrogenation. That is heat of hydrogenation. Hydrogenation means what? When double bond becomes single. Thermochemistry में किया, we have done all these things, right? Hydrogenate करते हो आप, C double bond C से C single bond C ला रहे हो. Right? That is hydrogenation. Double becomes single or triple become double. Now tell me, enthalpy of hydrogenation is maximum for which case? Magnitude wise. बताइए. पहले तो होता क्या enthalpy of hydrogenation, एक बार रिव्यू करा दो. First you have written this down. Can I remove this? I'll come to that. Can you recall 1, 2, 3, 4, 5, 6, 7? I'll not draw again. I'll just do it. Right. I'm removing it. So let's take this example. The 1 and 7. Just दो ही बनाते, बाकी आपको याद है. This was your 1 and this was your 7. लिख लीजिए. Now the question is heat of hydro or enthalpy of hydrogenation. Now first thing you have to understand is what is hydrogenation. Write down one line for it. adding 1 mole of hydrogen, to unsaturated gaseous molecule. The amount of heat released is called enthalpy of, or we can say heat of hydrogenation, right? The amount of heat released is called enthalpy of hydrogenation. Basically, if I write CH2, double bond CH2, in gas form, you add H2, gas form, you get CC, single bond, and all hydrogens like this. This process, whatever amount of energy will come out is called enthalpy of hydrogenation. Hydrogen, adding 1 mole of H2 gas on a given gaseous molecule to convert double bond to single bond or unsaturation to saturation. The amount of energy involved is enthalpy change, delta H. Now delta H, mostly it will be negative for it. Okay. Now think, had it been stable, if ये stable होगा, online people, if it is stable, to break this, you need more energy or less energy? Answer. Chinmay, if it is stable, to break this, you have to spend more energy or less energy?
Sir,
More
it takes more energy to break a stable bond.
Yes. So let's say earlier this was minus 100. I'm making it more stable somehow by changing groups and all. Let's say 50 I'm wasting in just breaking this bond. So the value will come down to 50 only. Let's say later I'm spending 80 here. So value will come 20 only. If I'm spending 90 there, the value will become 10 only. Is it clear, Shah? Are you understanding? So now the question is bigger and smaller. So I'll consider sign, with sign. With sign, this number is bigger. Minus 10 is bigger than minus 100 mathematically. But whenever you talk about heat of hydrogenation, generally the meaning is only magnitude. I repeat, only magnitude, not sign. ये इसका general meaning होता है. Ideally, examiner should be clear. They should clearly give you that with sign, without sign, what they want, but they will not tell you. Trust me, 90% cases they will not give. So you should know that only magnitude you have to consider. Basically, you will say this 100 is better than 10 if this question comes. But if this question comes, enthalpy word is coming, it has to be with sign. अगर इसके बाद भी कोई sign use नहीं कर रहा है, तो वो गलत कर रहा है. That person is wrong. Then this is my answer. कुछ समझ में आया? Again, this is a very common confusion. I'm again repeating the sentence. Adya, are you understanding this point? Niharika? I'm coming to that. Enthalpy of hydrogenation is delta H reaction is summation of product minus summation of reactant. यहाँ से आपको enthalpy में, right? But when you say heat of hydrogenation, it is just exchange of energy. We don't bother about minus or plus. So heat of hydrogenation is little tricky. I will suggest one simple thing. This is more reactive or less reactive? More reactive. No, this C, double bond C. This is less stable. This was less stable and it was more reactive. Since it is less stable, can we say in this case, maximum amount of energy will come out? Agree? क्योंकि सबसे कम stable है, तो इसको break करने के लिए कुछ लगा ही नहीं, आराम से reaction हो गई. Whereas in this case, energy will be consumed, hence energy release will be lesser. Are you understanding this or not? So अब मेरे को आंसर बताना प्लीज. अगर मैं बोलूं HOH and delta H, तो HOH का आंसर बता दीजिए पहले. 1 और 7. HOH max, HOH min, बताओ. मैक्सिमम हीट ऑफ हाइड्रोजनेशन किसके केस में मिलेगा? फिर से सोचो. मैक्सिमम हीट ऑफ हाइड्रोजनेशन किस केस में मिलेगा? हीट ऑफ हाइड्रोजनेशन मैक्सिमम कब होगा? जब ज्यादा एनर्जी निकलेगी. एनर्जी ज्यादा कम निकलेगी जब कम वेस्ट होगी. कम वेस्ट कब होगी? जब ये कम स्टेबल होगा. नो, हाँ 7, करेक्ट, 7. एंड दिस केस डेल्टा एच, डेल्टा एच ठीक बोला, करेक्ट. इधर मिनिमम में 1 and 7 आ गया, नोट कर लीजिए. Exactly. Enthalpy is with sign. That's what I've written here. It has to be with sign.
It's the same now.
It's the same thing, same magnitude. With us, just sign is there and sign is not there. Yes. Whatever I have told is also applicable for another term called combustion. Combustion क्या होता है? Burning with oxygen. So as you do hydrogen reaction, same as burning with oxygen. An alkene which is less stable, more reactive, will burn quickly, easily, will release a lot of energy. Its delta H will be minimum. Delta H will be minimum. And maximum HOH. Are you understanding? Whereas vice versa for the same. So hydrogenation और combustion दोनों में आप same काम चल सकता है and दोनों के answers आप कर सकते हो. Is it okay? Chinmay, Niharika and Nadia, is it clear?
Yes, sir.
All right. Please complete it, then we proceed further. Done?
Yes.
लिख लिया आप लोगों ने? Can you proceed further? चलिए आगे बढ़ते. So now just quickly see here. Heat of hydrogenation term is clear. ये सब मैं आपको डिस्कस कर चुका हूँ. Transes and all. Stability of alkene 1, 2, 3, 4, 5, 6. You know reactivity other way around. Carbon ion. Write down the heading carbon ion. Carb anion. Carbon ion मतलब C negative. फटाफट नोट करना, इसमें कुछ ज्यादा समझाने का नहीं, मोस्टली आपको चीजें पता है. C negative intermediate is called carbon ion. We have 3 sigma bond with 1 negative charge. Carbon is sp3 hybridized. There will be 3 sigma and 1 lone pair, so sp3. C minus is stable if I put something which can reduce this negative charge. You know that. You have to put something which can reduce the negative charge, right? Because anyway, be it plus charge or be it minus charge, you have to reduce in both the cases. You have to make it stable, electron withdrawing group, you have to keep to reduce the negative charge. That is how things work. And I hope that is very much clear also. Any problem? Anything new in this? It's all you know. Exactly reverse answer. Can I proceed further? So if I say CF3 minus and CH3 minus, which is more stable? If I say CF3 minus and CH3 minus, which is more stable? CF3 minus. Because fluorine pulls. If it pulls, minus charge will come down. If you have CH3 minus and CH3, CH2 minus, which is better? CH3 minus is better. Because CH3 pushes electron. If it pushes electron, it will increase negative charge. सोचो, negative charge is collection of water, condition of flood. ऐसा समझ लो, just for correlation, to like connect your brain in such a way that you can think quickly, right? So negative charge means, let's say water is electron. Negative charge means what? A lot of water. खूब सारे इलेक्ट्रॉन है वहाँ पे, तो क्या करोगे? वहाँ पे ऑलरेडी माइनस चार्ज है. आप बोलो वहाँ पे 2-3 नदियां और भेज देते हैं. Send 2-3 more rivers. Flood situation already problem. You have to pull. This is better. This is not good. Is it okay? If it is a plus charge, deficiency of electron, deficiency of water, drought condition, you have to supply water. Don't say that drainage is not ready. हाँ, flash flood आ जाएगा. So वो उतना भी नहीं geography में जाना है. See, अब ये देखो, यहाँ पे इंपॉर्टेंट चीज है. Alkyl group is a plus I group. You know that. अब यहाँ पे प्लस आई माइनस है, प्लस आई माइनस है, इसीलिए किया हम लोगों ने. CH3 is a plus I group. Plus I means it's a pushing group. No, this will push electron. This will push. There's a minus charge. So minus charge is already there. You are pushing electron. You are sending reverse. So it will increase. That's why it is poor structure. This is better structure. Is it okay? Next, if you have this question, can you solve this question? Negative charge CH3 is better than CH3 with 2H with better than 2 CH3 than 3 CH3. Had it been plus, exactly reverse answer. Now let me ask a question here. अभी कल ही कोई पूछ रहा था, कहीं पे तो discuss हो रहा था किसी doubt session में. If I give you a question, you have CH3, CH2, CH3. It is breaking heterolytically. Heterolytically, you understand? One will get plus, one will get minus. So how shall I break? Shall I keep plus here, minus here, or shall I keep minus here and plus here? Option A or option B? Think and answer. Don't be in hurry. A or B? How many say B? Raise your hand. How many say B? Raise your hand. How many say A? Raise your hand. Answer is B. Why? Because I will prefer minus charge here because it's CH3. And I'll put plus charge here because that's a stable situation as compared to CH3 getting a plus and CH2, CH3 getting a minus. Because this CH3 is a plus I group, will increase the minus charge. Here the plus charge is there, CH3 will support with plus I, will reduce the plus charge. Is it clear? That is the application of the same concept which you are learning right now. Is this question clear? Niharika, understood this point? So if you break heterolytically, how will it break? Adya, is it clear? Chinmay? Clear? Okay. चलो आगे बढ़ते हैं फिर. Now benzyl and allyl, these words we have done multiple times. Benzyl क्या होता है? Benzene ring and CH2. Allyl CH2 CH double bond CH2. We have done it or not? Number of times. So benzyl and allyl are reasonably good carbanion also. Okay. Why? Because minus charge can disperse like this. Okay. Check this example. Minus charge can disperse like this. Easy. Doable. Great. कर लीजिए.